Okay, so good morning, everyone. Welcome to our webinar today, which is on how to conduct the ANSI Z358.1 annual inspection. Just a couple of quick points here. If you have any experience, any technical difficulties, you can visit the link there that to go to webinar. That'll help you figure out any technical issues you may be having in either seeing what we're presenting or hearing us today. During this webinar today, we're going to have the ability for you to ask some questions, and you can post questions at any time during the presentation using the questions section on the control panel. It's on the right there. It says questions log. Any questions that cannot be addressed quickly or during the Q&A live will be answered via email post-webinar. The webinar will be recorded and available on demand and sent to you in a follow-up email within 24 to 48 hours after the presentation today. Poll questions will be launched throughout the presentation. We would appreciate it if you would participate in these poll questions. It helps us shape the content and the markets, really, for our future webinars. I'm your host, Dennis O'Neill. I'm the product specialist and trainer here at Haas. And every now and then you're going to hear another voice chiming in. That's Samantha Hoke, our marketing specialist.
Good morning, everybody. Thanks for being here today.
The agenda today is a few things. We want to talk about the importance of providing the proper first aid post-accident, ANSI Z358.1 requirements, how to conduct the test, compliance best practices, and then we'll have a live Q&A at the end for some of the frequently asked questions we get and some of your questions that you're posting during the webinar today. And that takes us to our first poll question number 1 for Samantha.
Thanks, Dennis. So we'd like to know what's your job function as it pertains to emergency eye washes and showers. Do you perform the weekly and annual testing of the equipment? Do you oversee the weekly and annual testing? Are you a consultant needing information on ANSI compliance? Are you a specifier needing information on equipment compliance? And if you're an architect, engineer, designer, please choose the specifier choice or none of the above. So as we launch these poll questions, I'm going to give everybody some time to answer, and then we'll close the poll and go back to Dennis. All right, thanks everybody. Back to you, Dennis.
Okay, thank you, Samantha. So what we're going to talk about here is the importance of providing the proper equipment. And prevention is what we're going to talk about here. And we always like to start with why. Why do we provide equipment? And when we talk about prevention, it's not really prevention of the accident. Obviously, our equipment is used post-accident. What we're talking about is the prevention of further injury or even fatality post-accident, overall general workplace risk, lost time, money, both for the individual and the company. OSHA has stepped up enforcement, particularly for employers who have a history of serious or repeated violations. And obviously the goal for Haas and everyone out there, I'm sure, is to go home safe every day. OSHA, or the Occupational Safety and Health Administration, states in 29 CFR 1910.151 the requirement that where the eyes or body of any person may be exposed to injurious corrosive materials, suitable facilities for quick drenching or flushing of the eyes and body shall be provided within the work area for immediate emergency use. Now this is the OSHA statement when you look up your requirements for your emergency drench equipment. In addition to that, some states require emergency eye wash and shower equipment in workplaces where irritants or chemicals are toxic by absorption. And that's stated in the ISEA Emergency Eye Wash and Shower Equipment Selection, Installation, and Use Guide. So it's important that you select or you look at your local requirements by your state.
So what's really interesting here is, as you can tell, OSHA is very vague as to what defines a suitable facility or corrosive materials. So for definitions and specifics, they recommend following the ANSI standard.
Good point. Thank you, Samantha. The American National Standards Institute, also known as ANSI, has written the standard Z358.1. Actually, the standard was written by the International Safety Equipment Association, the ISEA, which defines the emergency eye wash and shower design, location, and temperature requirements for proper functionality and usage. OSHA references the ANSI standard during site inspections and violation reporting. So while OSHA is very vague, they do recommend you comply with ANSI to ensure that you're OSHA compliant, as ANSI is the golden standard and the guide in the industry for proper use, installation, location, and testing of your emergency drench equipment. OSHA fines have increased. Not a lot of people know this, but OSHA fines increased for the first time since 1990 by as much as 80%. This actually went into effect August 1st of last year, 2016. An example of this is a penalty for a willful violation rises from the old fine of $70,000 up to $126,000 now. So a very significant fines in place if you're a willful violator, repeat offender, something you've been flagged for as a warning, you failed to correct. Those issues are now being looked at pretty strongly by OSHA with appropriate fineage to accompany those citations.
A really unique statistic that OSHA published, I believe it was in either 2015 or 2016, I'd have to confirm, but they audited over 39,000 organizations in 1 year, and 17,000 of those were labeled as unexpected visits. So that's kind of interesting and something to keep in mind. I'm going to launch poll number 2, if everybody could take a moment to answer the question. So before we get into the details of this webinar, were you aware of the weekly testing requirement for emergency showers and eye washes? All right, thanks everybody. Back to you, Dennis.
All right, perfect. Thank you, Samantha. So we need to discuss actually what is ANSI ISEA Z358.1 standard. And as we mentioned before, the American National Standard Institute standard was written by the International Safety Equipment Association to define emergency eye wash and shower design, location, temperature requirements, and proper functionality and usage. It was first published in 1981. Now that's important to note because Congress actually passed the Occupational Health and Safety Act in 1970, in which the full body of that OSHA went into effect in 1971. So for the first 10 years, all we had was that very vague definition of what suitable was. ANSI and ISEA got together, they worked on the standard. ISEA wrote the standard and published it in 1981 originally. That was the standard for almost 10 years. It was revised again in 1990, then again in 98, 2004, 2009, and 2014. So as you can see, we've kind of settled into about a 5-year pattern of when we expect to see revisions to the ANSI standard. The first revision in 2009 included a couple important things. Temperature range for water delivery. Previous standards only called out water range delivery as being tepid or tempered. That was very vague. Tepid water was kind of, no one really knew what that temperature range should be or was. So in 2009, they actually included the temperature range, which is 60 to 100 degrees Fahrenheit. We'll go into that a little bit more later. Simultaneous use, that was first introduced in 2009. It's important that both the eye wash and the shower be available for simultaneous use for a single accident. The testing requirements were revised a little and more narrowly defined in 2009. Then in 2014, these revisions included some design, manufacture, and installation requirements, more for the manufacturer side of what we're required to make sure that the equipment that we're providing is, and then the installation of which, of course, is up to the owner. Equipment installation location was also further refined and set forth in 2014, and then there were a few adjusted measurements, which we'll get into here in a second.
So in 2014, it was very minor revisions, mostly on the manufacturer side versus on the end user side.
Correct. Perfect. Thank you. Okay, so significant requirements and how to test for compliance. This is really what everyone's here for today. So let's start to outline a few of these. Now what we've done is we've kind of set these in order. It's very broad and ranging. The ANSI standard's well over 30 pages. So we've tried to narrow this down into sections that make sense. It may seem a little out of whack and kind of we're jumbled all over the place, but what we tried to do is put it forth in a clean manner for you. So in short, one of the significant requirements of Z358.1 is that all emergency showers and eye face wash equipment shall be inspected annually to ensure conformance with all applicable requirements of the standard. And that's set forth in a few different sections. So let's get into the meat and potatoes of this.
I just want to give a little background
Please.
real quick. So the way that we're going to go through this, as Dennis was touching on, is we're going to try to hit on all of the requirements that don't require activation of the unit. So typically when you're out in the field with your equipment and you're testing for the annual inspection, you're going to want to ensure you're checking the installation, you're doing the measurements, you're assuring alignment, and all this we'll get into detail prior to having to turn on the water. Otherwise, you're going to have a big mess everywhere. So as we go through this, we'll start with all the non-water requirements, and then we'll get into all the requirements after activation.
All right, perfect. So that being said, the first thing that we want to look at is installation of Eyewash and face wash equipment. Now, this is a measurement requirement, so unfortunately this one does require an activation, but the further ones will not require it. And what the first thing we want to look at is we want to make sure that the equipment is arranged such that the flushing fluid flow pattern is not less than 33 inches and no greater than 53 inches from the floor. It was previously 45 inches in the 2009 standard. Now what this means is not where your spray nozzles or your head is, but where the flushing fluid flow pattern is to meet the points on an Eyewash gauge, which we'll look at closely later on how to properly use a gauge and measure that. In addition, the minimum distance the eye face wash heads must be from the wall is 6 inches, and that just simply allows for head clearance. Most manufacturers account for this, and they're well off the wall, so that's usually an easy one to meet. The height one can be difficult, especially if it's not a pedestal mounted, if it's a wall mounted. So you just want to make sure that your flushing fluid flow pattern is not less than 33 and no greater than 53 inches from the surface on which the user stands. Not necessarily the floor. There are some manufacturers out there that have pressure plate operated eye face washes and showers, so it's not necessarily the floor line, it's the surface from which the user is standing. How do we test this? Well, it's pretty simple. We just use a measuring tape, check the point where the Eyewash flow meets the eye circles on an Eyewash gauge, then from there to the surface on which the user stands. And we'll get into exactly how to use an Eyewash gauge properly here in a second. Once again, minimum distance from the eye face wash heads is 6 inches, and once again, a simple tape measure check on that. Once these are installed, most of these are permanent installations, so fairly easy to know that once it's installed correctly, you're going to probably meet this year after year after year. But it's important to note it's not the height of the bowl, it's not the height of the head, the nozzles, it's the flow pattern, which can change over time due to corrosion in pipes, dirty water, plugged heads, things of that nature can restrict your flow eventually, and you'll have varying flow levels. Even though the equipment is mounted exactly where you want it to be, flow heights can change over time due to various circumstances, so that's important to keep note of. Showers and combination units. Shower head must be 82 inches minimum, 96 inches maximum above the floor or the surface on which the user stands. The actuator, also called the pull rod, must be no more than 69 inches from the surface on which the user stands. We want to make sure that people of all heights can reach the pull rod to activate. And the height of the shower head is very important because of flushing fluid flow patterns, which we'll get into in a second here. But significant deviations in your shower head height changes the flow pattern of the shower itself. So it's really important. Most manufacturers have their equipment designed to operate fully to the standard between 82 and 96 inches. Once again, very simple test. Just use a tape measure, check it. Once again, it's a permanent piece of equipment. Generally, these aren't moved around, so once it's installed correctly, you can be sure, usually from year to year, that that height hasn't changed. Obviously, there's accidents, forklifts bang into it, things of that nature can knock things out of alignment. So once a year, put a tape measure to it just to make sure you're still within your height requirements. Simultaneous use. This is an important one, and this is something we commonly see in the field when we do our field inspections. We want to check that the Eyewash and shower are aligned for simultaneous use by the same person. As you can see on the picture on the right, the eyewash bowl is several inches to the left of the actual shower head. This would not be compliant. We want to make sure that when a body exposure happens, the victim can comfortably and easily use the eyewash while the shower is activated over the head of them, rinsing the rest of their body. On the picture on the left, as you can see, complete alignment between the bowl and the shower head, which leads to simultaneous use. Very important, and a common thing we see out in the field as a miss. All nozzles, outlets, or even stored flushing fluid must be protected against airborne contaminants. We want to ensure dust caps and covers are the correct fit and are in place. This is really important. These can fill up with debris. You can see on the right there's a fairly dirty plant of some sort. The eyewash nozzles are not protected. This leads to a couple of issues. The first is your flow could be restricted greatly by contaminants or any particulate matter filling up the eyewash nozzles. In addition, once the water starts spraying out, those irritants and the things that have collected in there are now being introduced into the eye, at least for that first initial push. So it's very, very important that your dust covers are in place. It's going to perfect performance and also prevent any further injury to the victim trying to use that piece of equipment. As you can see, the product on the left, a dust cover securely in place, and on the right, just open portholes, which are obviously not going to be compliant.
So Dennis, I believe I was reading an article recently, or not an article, a violation citation from OSHA, and something as simple as the dust caps not being in place was a $500 fine. It may not sound that bad, but times as many units that you may have, and then that gives, of course, OSHA the option to, come back into your facility and check again for repeat violations. So it's very important to make sure that you're following the standard even all the way down to a dust cover.
Absolutely, and that's a great point because this is just a few dollar piece. It's a very simple piece to obtain and acquire, and for a few bucks you can make sure you're not opening up Pandora's box to OSHA. Once they're in there for one violation, they can begin to check everything from your emergency drench equipment to your fire extinguishers, whatever else it is that they need to check. So you really want to make sure you're compliant in all areas. This is another important one. All emergency eye washes, eye face washes, showers, and combo units must be accessible within 10 seconds from the hazard, must be located on the same level as a hazard, and the path of travel must be free of obstructions. There is one small consideration to this when we're talking about being located on the same level as the hazard. In the 2014 revision in the Appendix B, Installation Considerations, they have now allowed a single step into an enclosure where the equipment can be accessed is now not considered to be an obstruction. This is to allow for what we see on the picture here, emergency booths that are located outside, generally in cold weather or extreme weather environments. These usually are skid mounted, and so there's usually a small lip, less than 4 or 5 inches, into the enclosure. That being said, a berm is considered an enclosure. If you had to walk up a stair or two to reach the equipment from where your hazard is located, that would be considered a hazard. It would be considered, I'm sorry, not a hazard, but an obstruction, and no longer on the same level as the hazard. We have to remember the victim is most likely in a state of duress. They many times cannot see. We don't want to further their injuries by having them have to navigate a difficult path, navigate stairs, go up different levels, go down from a level. We want to make sure the equipment is on that exact same level. The 10-second rule, let's talk about this real quickly here. This is always a difficult one. It's the path of travel that an average person can travel at normal walking pace in 10 seconds. This is one of the most common things we get questions on. ANSI kind of narrowed this down a little bit, and they refer to 55 feet. That's not an exact measurement. We would like to see it closer than 55 feet. Obviously, the best scenario is your emergency drench station is adjacent to the hazard within a second or two. That's not always possible. Some of these rooms are large where chemicals are stored, and there's many, many vats of chemicals, and so you can't put one at every single station where there is a chemical hazard, but within 10 seconds is really, really important. 55 feet is the rule of thumb. To be safe, I would call it 50 feet or less. So how do we test this? Really, you need to check for the proximity of the hazard, like I mentioned before. We would like to see it as close as possible. As I mentioned, 10 seconds walking pace is a fair measurement. We want to make sure it's located on the same level as the hazard. Confirm the equipment is on the level as the potential hazard, no stairs, different floor like we mentioned. You can see on the right there's some examples of these issues, the double stairs there. On the picture on the left, you can see there's a lot of equipment, hoses, piping in front of the eyewash station. Very difficult to access it. Even on the right bottom, you can see there's a small tripping hazard. It's great. They put a drain in. They've considered you want to consider that this is contaminated fluid coming off these things, and generally you want to drain and collect that somehow, but you don't want to make another impediment, a tripping hazard for your employees. Ensure no obstructions are in the path of the travel to the equipment. Emergency eye washes, eye face wash showers, and combo units must be well lit and identified with highly visible signage. Deliver flushing fluid for a full 15 minutes, and the actuator shall be simple to operate and go from off to on in 1 second or less, and remain on without the use of the operator's hands. This is really important. It can't be a self-closing valve. Once the actuator is open, it needs to stay open. That way the victim can use their hands to keep their eyelids open while it's in an eye face wash, remove potentially contaminated clothing. These things are all important. You don't want to be relying on one of your hands to be working the equipment. You have to have the use of both of your hands.
On that bottom point of going from off to on in 1 second or less, a lot of people will come to us up at a trade show or contact us and say, well, isn't it one motion? That's something that has never been in the standard since its inception in 1981. It is absolutely a misnomer that's out there in the industry. I'm not sure if it came from another manufacturer, but it has spread itself around. There is no requirement or anything in the standard that says the unit needs to be activated in one motion. So for example, manufacturers have faucet-mounted eye washes that require the activation of the water and the twist or the activation of the eye wash, which, as you know, is a two-motion activation. That is compliant as long as the equipment has been certified by CSA to the ANSI standard that it can go from off to on in 1 second or less.
Great point, Samantha. That is a very, very common misconception out there. One motion, for some reason, is in the mind of many people, never been in the standard, as Samantha mentioned. So how do we test for these? Well, well lit. This is a difficult one. There is not actually a lumens or a measurement for a light measure. Basically, it just says well lit. So that's really up to you to make sure that your equipment is well lit. Easily identifiable with highly visible signage. Proper signage, adequate lighting, very important. Your people need to know where to go for this equipment. And once again, if they're in duress, they need to be able to locate the equipment easily.
And the signage is provided typically from your manufacturers.
Absolutely. When you purchase a new unit, it will always come with a sign, at least from Haas for sure. Deliver flushing fluid for a full 15 minutes. Annually, it is required to run each piece of equipment for a full 15 minutes and monitor flow. This presents a lot of problems. We understand that. But it is what it is. The standard requires this. There are companies that are working on providing ways to collect this water, whether it's big portable tanks, but when we're talking a 15-minute run for a shower at 20 gallons a minute, that's 300 gallons of water that needs to be collected somehow if there's no drain available. It's a big issue out there. I can tell you Haas is actually looking at a couple of things to help with this. Unfortunately, we have nothing yet as far as water collection, but we're working on things to help with this. Go from off to on in 1 second or less, remain on without the use of the operator's hands. Simple test. Evaluate your activation device. Ensure the water flows in 1 second or less. When you push or pull your rod, push your eye face wash, water must be available instantly, immediately. As you can see, the gentleman here is using the equipment. No hands required. Stay open valves. Easy test. Emergency eye washes, eye face washes, showers, and combo units must provide a controlled flow of flushing fluid at a velocity low enough to be non-injurious to the user. That's really important verbiage here. At a velocity low enough to be non-injurious. Your equipment may meet all the minimum requirements, and as I don't believe I mentioned before, but all requirements set forth by ANSI are minimum requirements, not maximum flow requirements, minimum only. Flow controls can help in non-injurious for the non-injurious verbiage of this. We can see a piece of equipment that will meet the minimum flow requirement, but the flow will be very aggressive, maybe at times 2 or 3 feet. You've probably seen this in your own facilities at times, 2 or 3 feet above the eye wash bowl, you can see water shooting out. Well, of course, it meets the minimum requirement, but the non-injurious to the user requirement is something really important to be considered. No one wants to stick their eyeballs in an eye wash that's really aggressive for a full 15 minutes. It won't lead to a comfortable use, and the victim's likely not to stay for a full 15 minutes. We can confirm controlled flow of flushing fluid. You can confirm that that requirement is met with your eye wash gauge.
So as you could see in the previous slide, that combination shower and eye wash is providing, and we'll get into the flow rates, but just for reference, it's providing a total of about 23 gallons per minute at 30 psi. So that's about 10 times the flow rate of your shower at home. So take that into consideration. So on the manufacturer's end, it's really important to provide a soft flow and even distribution to promote the 15-minute drench time, and take victim consideration into comfort. Or, I'm sorry, victim comfort into consideration.
Exactly. Victim comfort is very important. It's often overlooked. But when someone is in a distressed state, they want to make sure that they are getting their full flush. It's very difficult to do with really aggressive spray patterns, really aggressive water. It's hard on the skin. It can be hard on the eyes. So a soft flow, a nice smooth laminar flow is really important. The flushing fluid shall cover the areas between the interior and exterior of a gauge at some point less than 8 inches above the eye wash nozzle. This is really important. So what we want to make sure here is that the eye wash gauge, which is a measurement set forth by ANSI, it's basically the average distance between the ocular sockets of the average person. So an eye wash gauge, your flow patterns must meet the points of that gauge. The water flow pattern has to be hitting those eye wash sockets at 8 inches or less above the nozzle. Really, really important. This is a common miss in the field. People say, I've got my minimum flow rates, but as I mentioned before, there can be several 3 or 4 feet of spray coming out, and your eye wash pattern might not actually meet that requirement of some point of less than 8 inches from the nozzle. Really easy to measure. You just use your tape measure along with an eye wash gauge while the unit is activated to make sure your height requirements are being met. That's, once again, not where the top of your water ends, but where they meet the points on that eye wash gauge. Here's an example of what I was talking about. As you can see on the top picture, that's just really aggressive flow. Perhaps it's meeting the eye wash gauge. I would look at that and just off the top of my head say it's probably not meeting the points of the gauge less than 8 inches, but that's an easy test. Get your eye wash gauge up there, make sure your flow pattern is hitting those points at a point of less than 8 inches. And on the bottom, as you can see, far too little flow. That's just too wide of a spread. That's going to be much wider than the average human, your ocular sockets are going to be. It's just not going to provide flushing. Basically at that point, you're picking which eye you like better and trying to save that one. The minimum flow rates for an eye wash only are 0.4 GPM, gallons per minute. An eye face wash, which is a very different piece of equipment, is 3 gallons per minute. Generally, the way to tell the difference is most single port or single opening flushing heads are eye wash only. The top one could be considered an eye face wash. It has multiple spray. It's probably going to get a larger volume of water to your face. It looks like they're for sure meeting the 3 GPM. I would challenge that one possibly, though, isn't meeting the gauge at the proper height of 8 inches or less. Flow rates. This is a difficult one to measure in an eye or an eye face wash. Much easier to do in a shower with some simple equipment. It's simply just really hard to collect the water. As you can see, most of the time these are over a bowl. The bowl then goes into a drain pipe and it's disposed of. Difficult to actually measure your true flow rate. You can put a flow meter on your feed line. That's really just your supply. That's not measuring the true flow from the heads. As I mentioned before, there could be restrictions of debris in the head, dirty filters, inline strainers that are in the heads, bad flow controls. That can all lead to restrictions from the actual output of the head. So what we like to do is for this one, to make sure you're meeting your flow rate, is once again we use the Eyewash gauge. We make some assumptions. This can be tested at the same time as you're using your 8 inches or less conformation. Simply place the Eyewash gauge while the unit is activated. Ensure the water hits the Eyewash circles at the gauge some point less than 8 inches. Most manufacturers, I know Haas for sure, we do all of our testing in-house. We know that when we put out a piece of equipment, we're easily meeting the 3 GPM standard on our eye face washes. So if your water is hitting the gauge, you can make an assumption that you're probably hitting your minimum flow requirement. Once again, those are minimum requirements, not maximum. The shower. Drenched showers have a 20 GPM requirement. That's a lot of water. 20 GPMs is going to be 300 gallons over a full 15-minute flush cycle. The minimum sufficient flow and volume to both shower and eye face wash for simultaneous use. As you can see in the picture here, that's just too little flow. It's not going to meet the GPM requirement. It's not going to meet flow pattern requirements. There are multiple issues with that one there. So how do we test this? Well, this is how Haas tests flow rates for the shower head. You need a few basic pieces of equipment, a 5-gallon bucket with a 2-gallon water line marked somewhere on the bucket, what we call a shower sock with a pole on it, so you can put the shower sock up around the head, and then a thermometer. We like to test a few things at once, and so if you get your thermometer involved here as well, it's a great way to tick off a few things on your testing. Place your thermometer in the bucket. We like a pool thermometer is great, a little waterproof thermometer. Place the shower sock around the shower head and into the bucket. Activate your shower for 6 seconds. You want to check that the 2-gallon water level mark on the bucket is met. 6 seconds of flow equals 2 gallons of water. That translates to 20 GPM. So instead of running for a full minute and then trying to figure out what to do with 15 gallons of water, you can put that around for 6 seconds, have someone count for you, make sure your 2-gallon water is marked, and then you know you're meeting your 20 GPM requirement. At the same time, you can use that thermometer and get your temperature measurements. So it's a great way to kill a couple birds with one stone there. Shower head water distribution, also known as flow pattern, must provide a column of water 20 inches wide at 60 inches above the surface on which the user stands. Flow pattern is important. This ensures that your whole body is going to get covered. As you can see on the left, great flow pattern, nice wide distribution of the water. On the right, not the same flow pattern. Obviously, there are some many issues with that one, but the flow pattern obviously is not being met here. Once again, a really simple one to measure. Use a tape measure when you use it activated to confirm compliance. All you need is 20 inches at 6 feet. It's fairly simple. You only have to have the shower running for a second or two. Turn it on real quick. Make sure you've got your 20-inch wide. Most manufacturers meet this one fairly easily as long as your shower head is installed at the correct height, as we mentioned earlier. Significant deviations of the shower head height, particularly too low, can lead to improper flow pattern. So when it's too low, you can see the way the cone comes down, the cone of water. You're not going to meet your 20 inches at 60 inches requirement if the shower head is too low. Combination unit meets minimum flow and volume when both activated for simultaneous use. Simultaneous use is huge. This is probably the single biggest issue we see in the field when we do our on-site inspections. The shower might work great by itself. The eye face wash might work great by itself when they're the only things isolated working. Once you turn on the shower, what we call starvation can occur very commonly. What we want to make sure is when you activate both the eye wash and the shower head together, you're getting your flow and they're at the same time with no starvation. Many times without flow controls, the eye face wash heads are starved of water. The 20 GPM is rushing to the shower head and you're losing your flow from your eye face wash. This is critical. This has got to be met. It's very important. HAWS can help you with this if you're having issues with this, so reach out to us after the webinar if this is an issue you have. We can definitely help solve it with our AX kits. But this is probably the single most common issue we see as a failure point in the field when we do our inspections. So, not always easily solved. It could be piping issues, improper PSIs, things of that nature. But if everything is there that we need as far as piping size and PSI, and you're still getting this issue, it's an easy solve for us. So just reach out to us and we can help you with that one. Emergency eye washes, eye face washes, showers, and combo units must deliver tepid flushing fluid, which, as we let you know earlier, was now defined as a minimum of 60 degrees Fahrenheit up to 100 degrees Fahrenheit. That's 16 to 38 C for our friends up north. 75% of ophthalmologists say that having tempered water is very important, citing it increases the chance that a victim can tolerate the 15-minute flush required. Particularly important for the full body flush. Anything below 60 for more than 15 minutes can lead to hypothermia, particularly if you're in an outdoor situation. Let's say Minnesota in the dead of December, you're not going to want to stand there in 60 degrees water for extended time. I would say you couldn't take it for more than a minute, much less a full 15-minute cycle. Very important you have tempered water coming to the victim. Victim comfort is very, very often overlooked. Victim comfort, though, is the #1 thing that leads to a full 15-minute proper drench cycle, as most SDS sheets require. Now, consult with your SDS sheets. Many require a 20-minute or even longer, but the most that we found is 15 minutes. ANSI requirements are set at that 15-minute baseline, so you want to ensure that what you're working with is covered here.
A couple key points on that. Interestingly enough, there was an old naval study that claimed that the human body can withstand 60-degree weather for a full 20-minute flush without hitting hypothermia. So, from the manufacturer's end, we've been talking with the ISEA group saying we'd really like this range to be closed in a bit. Your average person not in the Navy and being trained the way that they're trained typically and probably will not be able to withstand 60 degrees Fahrenheit. So as Dennis was mentioning, victim comfort is a big piece, and a recommendation, at least from the HAWS end, is setting that temperature range more towards within the 80-degree temperature range. So keep in mind the equipment isn't compliant for tepid water at the purchase, but rather at the installation and after testing. Many people think that tempered water is only for cold regions, but hot water is often overlooked. So for example, locations like Saudi Arabia.
Perfect. And even in Texas, you've got exposed piping. You can get ambient temperature in the exposed piping well over 100 easily, quite easily, in fact, on really hot days in the summer. And the reason it was set at that upper level was of 100 is because there are studies that show that temperatures above 100 can actually begin to cause damage to the soft tissue of the eye. And so in order to keep exacerbating any injuries or furthering any injuries, we want to keep that temperature below 100. When people purchase equipment from HAWS, our mixing valves and tempering systems and things of that nature are preset here at the factory at 85. So we prefer an 85-degree range. We just think it's a better range, but this is the standard as it is right now. And as Samantha mentioned, we're working with the ISEA on future revisions. We'd really like to see that range closed up a bit. And as an interesting side note, the average person takes their home shower at a 2 GPM shower head in most instances at around 102 degrees. So you can see how cold the 60-degree shower would be. It's quite significant. Testing for your temperature, really easy. Just use that thermometer that we suggested. A great pool thermometer works great. They're waterproof. You can stick it in the water flow. It can be conducted during the shower head flow test rate. Place the thermometer in the bucket, activate your shower head, place your thermometer in the water long enough to get a great reading. If it's a eyewash only, go ahead and just leave it in the flow of the eyewash for a few seconds until you feel like, or however long it takes, till you feel like you're getting a great reading. For eyewash, eye face washes, just put it in the stream until you can get that great reading. All right, Samantha, another poll question.
Sorry about that. Thanks, everybody. So the next question on your screen, we'd like to know, are weekly inspections currently being conducted on your equipment? We're about to get into what the requirements are for the weekly test versus the annual test. I'm getting a lot of questions there, so we'll clarify that here in the next couple slides. But if you could take a moment to answer this poll question, it would be appreciated. All right, thanks everybody. Back to you, Dennis.
Okay, portable and self-contained equipment. This is a little bit of a different beast. Many of these you do not want to activate weekly because you don't want to get rid of your drenching fluid that you've got in there. Many times it's protected with a bacteriostatic preserve of some sort. Some of the other manufacturers out there use a bladder system where it's a self-contained saline solution in a contained bladder that you only need to change every year or two or even longer, and you don't want to puncture that bladder and cause an activation. So the determination by ANSI is these must be visually checked weekly. You want to make sure the flushing fluid is still present and that it doesn't need to be changed or supplemented. In other words, you haven't lost any due to evaporation, there hasn't been an activation where someone maybe didn't notify the powers that be that order and check this equipment. And the fear is here that in a portable, someone needs to use it and they go to, they pull that lid down or they activate that device and it's just not enough. There's no fluid there. That's an issue. So a visual inspection is great, and that's really all that's required for portable or self-contained equipment. You want to also inspect it annually to assure conformance with installation requirements of the standard. Many times portable equipment is designed just for that, maybe construction sites, or it's a place where maybe you're doing a load unload of a particular chemical way in the back 40 of large facility, and that equipment gets moved around. So harder to check that annually, but again, these are going to be required to be in line with the same installation requirements. So that minimum of 33, that maximum of 53 inches for the flowing pattern, things of that nature, they're still going to be required.
So to recap, because I'm getting a lot of questions, portable self-contained units only need to be visually checked weekly, but they need to go through the entire full annual inspection that we just went through, that plumbed units would also be going through.
Correct. Yes, exactly. Not weekly activation, not required for a portable unit, a visual inspection. And once again, what you're really checking there is to ensure you've got a full unit. It's ready for the next user, potential victim. There's no attrition, no loss of water or flushing fluid due to evaporation. There hasn't been an activation that no one let someone else know about. So we want to make sure, at least weekly, that the flushing fluid is available. Very important. Thanks, Samantha. Weekly required inspections continued. All plumbed emergency eye washes, eye face washes, showers, and combo units shall be activated weekly as well as annually to ensure compliance with ANSI. Weekly activation is really, really important. We want to make sure that the water is actually available, that there hasn't been a shut-off valve somewhere down the line that someone forgot to turn back on. We see this happen in schools, believe it or not, in school labs frequently. Water is shut off by the maintenance staff for the summer. Students come back in the fall. No one remembered to turn the line back on. There's an incident and there's no water to the emergency equipment. It can happen a lot during maintenance, plant shutdowns for whatever it may be. Really important to make sure that you're doing your weekly activations to make sure that there's water still available to the device. That ensures the flow of the water to the heads of the device. The duration of the activation, this is kind of a difficult one. The verbiage is, it shall be sufficient to ensure all stagnant water is flushed from the unit itself and clears all dead leg sections of the piping. Stagnant water begins to grow bacteria. It just is what it is. Water in the dead legs can begin to grow bacteria in as quick as a week. That's why the weekly activation was set up. A lot of people refer to this as the bump test. They kind of turn it on for a second, make sure the water's coming out, and then they turn it off. Well, it's got water to it, it's fine. Technically, it's not. You want to make sure, you want to follow your dead leg back to the main flowing, recirculating line. Make sure you have cleared that dead leg appropriately. There can be bacterial growth in there, and the last thing we want to do is introduce bacteria into a victim, into their eyes or to their skin. Some best practices. Additional weekly checks are recommended to fully ensure the equipment is functioning correctly and is capable of providing proper first aid. Testing procedures should follow the previously explained testing that we talked about, but also weekly what we recommend you do is check a few other things. Your access. Make sure the path of travel is free of obstructions. This is really a key. We see this a lot. Pallets are temporarily put somewhere and then they're not moved, and all of a sudden the next thing you know, that temporary pallet that someone dropped in front of the Eyewash station becomes a permanent pallet because that's just where that belongs now. Well, that's not where it belongs. It belongs somewhere else free of obstructing the eyewash or the shower. Your delivery of tepid flushing fluid. Once again, really important to check that weekly. Just throw a thermometer to it. There can be failures. There can be any number of things that can lead to your tepid water no longer being tepid. Some other best practices: make sure your outlets are protected from airborne contaminants, so your dust covers are in place. Your valve was off to on in 1 second. Flushing fluid shall remain on without the use of the operator's hand, so it's still hands-free, simple to operate. Are you meeting the points of your gauge at a point less than 8 inches above the eyewash nozzle? Really important. This one can change over time, like I mentioned, because of unclean water, hard water, a lot of sediment in the water can start to clog over time. Your piping, your inline strainers, possibly filtration that you have on your water lines. So your flow pattern can change over time. Just because it's good 1 week does not mean it's good the next week. Things happen and things can get lodged in the heads. Really important. Controlled flow to both eyes simultaneously at a velocity low enough to be non-injurious. I can't stress this one enough. This is really important. Just because you have that minimum flow does not mean you're not blowing out the eyeballs of the victim. It's got to be a nice, low, smooth velocity, non-injurious to the user, that encourages them to remain in the eyewash. If it's uncomfortable, or it could actually even be dangerous, there's too much pressure on the eyes, you just want to make sure that it's a nice, smooth, comfortable flow for your victim. Shower, deliver that minimum of 20 GPM. Once again, easily to do with a 6-second test with your bucket and a sock. Valve off to on in 1 second or less, just like the eye face wash. Flushing fluid should remain on without the use of the hands. Combination unit, capable of operating simultaneously. Make sure there's no starvation occurring. When you activate your shower, your eye face wash still remains robust, meeting those minimum flow requirements. All right, poll question number 4, Samantha.
Thanks, Dennis. So the webinar is not over. Not time to leave yet, but we wanted to know, now that you've watched the bulk of the webinar, in your opinion, how much of your equipment is compliant with the standard regarding installation, activation on the weekly and annual basis, positioning, well lit, all the stuff that we just went through. All right, thanks everybody.
Okay, so ANSI Shower Eyewash Survey Program. HAWS actually offers a program to help you make sure you're compliant. It's a complimentary shower eye face wash survey. We have professionals all across the United States and Canada. They're representatives, Haas. They've been ANSI trained here at Haas, here at the factory. They know what to look for, help you mitigate your risk and ensure compliance. What this would include is 1 full day of inspections. Now, we understand there are some facilities out there that may have literally hundreds of stations. We've been to very large facilities that have well in excess of 500 stations. Obviously, we can't do that in a single day, but what we can do is come in, give you 1 full day. Our well-trained rep can easily get 30 to 50 units done in a day, depending on distance apart and how much travel is involved between station to station. But we can give you a nice wide sampling of your stations if you have a very, very large facility. We will provide at the conclusion of the survey an inspection report as an executive summary chart, basically like a pie chart that shows kind of where you're at. It's an easy one-piece page to hand up the ladder for those that make decisions if it's not you as the decision maker on your emergency equipment. We can provide recommendations on how to get you compliant from your current state. And then we provide a debrief meeting. It's usually like a web conference or phone call where we can go through the specifics of what we found. There are some restrictions, so if you want to find out if you do qualify, you can go to www.hosco.com/survey, fill out a form there. That actually comes to me. I'll evaluate the information, send it to our local reps. They'll contact you, and they'll work with you to make sure you qualify, and then we'll go from there. What we've found is we've done several hundred surveys at this point. This information that's a little bit older, we found about non-compliance is about 78% for performance issues. So basically about 4 out of 5 units are not really truly compliant to the standard for performance issues. It's a huge number. It's a problem. It's kind of a hidden risk that people aren't aware of. So let us help you identify where you're having your issues. And Samantha.
All right, so Dennis said you could either go to the URL that was on that page prior, or here's a poll question. So if you would like somebody to contact you, Dennis will make sure it's routed to the correct person and we'll get someone in contact with you. Hit yes. If not, please hit no. We have just a couple more slides and then we'll get into some of the Q&A. We have tons and tons and tons of questions. And as Dennis mentioned, we're not going to be able to get to all of them, but we'll make sure we're going to send out in about a week a follow-up email with the Q&A document. It'll have a lot of the questions that were asked today with the answers, and then anything that wasn't answered through that, we'll follow up with email.
Okay. One other important thing to talk about is Zavato. Zavato is an independent third-party service company. They actually are the warranty provider for Haas field service emergency shower eyewash equipment. They are very, very capable and trained on the ANSI standard. They can help you with many things: startup and commissioning of your equipment, annual ANSI inspections. They actually provide online person training, competent person training, and certification for people at your facility. You probably have people at your facility in charge of going around and doing your weekly inspections and activations. This actually trains them on exactly what to look for. All the points that we just went over, it's an online certification. I believe it's good for 2 years. It's a minimal cost. They also provide wireless alarm site surveys and installation, repairs and upgrades to your equipment, warranty service, preventative maintenance contracts. Really, they are the people you can turn your shower survey program over to, and they can handle it for you. Really great company. I recommend them highly. They can be found at www.zavato.com.
All right, I'm going to go over some quick resources, and I really want to get to some of the Q&A. We are going to provide you in the follow-up email our weekly and annual inspection checklist. It's one piece combined, but anything required on the weekly basis is noted with a W. There's also access on our YouTube page to an ANSI Z358 standard webinar that's very similar to this, but it gets a little more detail into the requirements. This webinar was more about how to actually conduct the test. We have a risk-rated response tool on our website that'll help you select the correct equipment based on, the level of corrosive materials, the level of coverage you need, etc. We have our ANSI white paper best practices that will also be in the follow-up email that'll go out today. Earlier, Dennis mentioned we have a anti-testing kit. That's a lot of questions came across wondering if we have that kit. Yes, it is model 9011. It includes the gauge, the thermometer, the bucket, the shower sock, the rod, etc. We talked about the site surveys, and then we have a full page on our website, hosco.com, that just gives you a plethora of information on the ANSI standard.
All right, so we have a few FAQs. You've sent in a ton of questions. Samantha's kind of put together a few here that seem to be the ones that are coming in the most. So let's go over this real quick. Portable gravity eye wash stations. What's the requirement for draining and refilling the tank for a portable? There are a couple different designs on the market, so I really can't give you a specific standard you should follow for this. The ANSI requirement, though, is that any portable or self-contained eye wash shall be visually inspected weekly to determine if the flushing fluid needs to be exchanged or supplemented. The unit should be maintained as the manufacturer's specific model instructions, though. For Haas and most of our other manufacturers' units, we use potable water and a sterile bacteriostatic additive. It's required every 3 months, as well as rinsing the unit clean between exchanges. If you're not using an additive, the water should be exchanged on a minimal weekly basis, because after 1 week, bacteria can begin to grow. So a thorough tank cleaning is important. All right, another question that's come in. What is the minimum maximum pressure and flow rates must be supplied to emergency equipment? Per ANSI, for plumb units, the minimum is 30 psi. There is no maximum as related to the ANSI standard, but in the appendix it does state that pressure in excess of 80 could be injurious. Haas equipment actually operates comfortably between 30 and 90 psi. Our flow controls ensure that between those pressures we will get full flow in operation and flow patterns. We have built-in flow controls that ensure that. Another one, how close does supplemental equipment need to be to a full standard equipment location? Supplemental equipment are the personal eye wash squeeze bottles that you'll see. The ANSI standard does not call out a distance as far as the installation for a personal eye wash. The intent of this is simply a supplemental piece of equipment. It's immediate flushing to the victim while the victim is en route to a primary station or even a medical facility. They do not replace the requirement to have a 15-minute primary station. They do not take place for a station. A station is still going to be required within 10 seconds of that hazard. These are simply a supplemental piece of equipment and cannot and do not take the place of a permanent or fixed station.
All right, Dennis, we're going to get into some of the Q&A. I know we only have a couple minutes, and I'm going to answer just a couple of them. So someone asked, do you recommend that your equipment and your signage follow the ANSI Z358.1, which is the standard for color coding? Yes, we do recommend that, although it is not required. You'll see a lot of the other manufacturers have different colors. Red typically equals danger, yellow equals caution, orange I believe is warning, and green equals safety equipment. So all of Haas equipment is green for that recognition factor. Another question, Joshua wanted to know, can dust covers be improvised with things such as lab plasticware, or does it need to be the manufacturer's? The ANSI standard doesn't have any requirement. It just says that the outlets need to be covered. We obviously recommend you stick with the manufacturers, and we have replacement dust covers if those were to ever break, because we have manufactured them to fit properly, and then when the unit is activated it needs to be able to flip off without the operator taking that dust cover off. So you would need to be very careful if you're creating them on your own. Dennis, another Josh was wondering if there is a grandfather clause. So if they have equipment that may meet previous year's standards and there was a recent update in 2014, does it need to meet the 2014 standard?
Absolutely not. No grandfather clause in place. If the new standard comes out, all existing field equipment must adhere to the new standard, regardless of if it met previous standards. Once the new standard is out, that is the new law of the land.
Okay, a couple more questions. Dan wanted to know, is a door considered an obstruction?
Tricky one. A door is considered an obstruction. It's also not considered an obstruction. Here's the way you need to look at it. If the door opens in the direction of travel from the hazard to the station, and the door does not have the ability to be locked, then it is not considered an obstruction. Let me rephrase that. If I have to pull the door towards me, it's an obstruction. If the door has the ability to be locked, it is an obstruction. Not that the door is unlocked. The door must never even have the option to be locked. It must open in my direction of travel and never have the ability to be locked to be not considered an obstruction.
Thank you, Dennis. Again, we have tons of questions. We'll make sure to hit on them, but it's 11 o'clock. You all have to get to your next meetings, I'm sure. But we both want to thank you so much for attending today. We'll make sure we get that follow-up email out today and then another one following in the following week. Thank you all again. On the screen, we've got Dennis's contact information and customer services contact information. Feel free to reach out to us, and thanks again for attending today.
Excellent. Thank you, everybody. Have a great day and stay safe out there. Thank you.